All right, so today we're going to start on the next module, which is loops. Hopefully you did well on your, I haven't graded them yet, but the labs from yesterday on conditionals. If you have any questions on those, go, of course, post to Piazza. We are live here, so if you have any questions, you can post to Piazza or to YouTube. But otherwise, we're going to start talking about basic loops, for loops, and while loops. You might have seen do-while loops. I'm not going to cover those because they're fragile, they're brittle, and a for loop, while loop, keep it simple, keep those two. In Java, though, we will cover enhanced for loops, which are for each loops, but they don't use the keyword for each. So the whole point here is that we need a way to repeatedly execute blocks of code over and over again, right? You don't cut, paste over and I need to do this 5 times, right? You don't cut and paste it 5 times. And to do that, you use a loop construct, right? A construct in code that says, repeat this piece of code until some condition is no longer satisfied. In fact, you can break that down into 4 basic elements to any loop control structure. An initialization statement, because if you're running around in a loop, right, on a track or something like that, you have to start somewhere, right? You didn't just get there, right? So that's the initialization statement, where the loop starts. Then you have a continuation condition. If I'm running around the track, how do I know when to stop running, right? I need the coach says, okay, you've run 10 laps, you're done, stop, right? You need, before that though, you have a continuation condition. You haven't reached 10 laps yet, so continue until you do. And the opposite of that is just the termination condition, that once that's no longer satisfied, then the opposite, right, conditionals, the negation of that takes over and the loop ends, terminates. But also you need to be making progress towards that termination condition. Otherwise you have what's called an infinite loop. If the coach never tells you to stop, right, great, 10 laps, keep going, right? And you're going to go on infinitely running around that track forever, right? So you need to make progress towards it. And then of course you're doing something in that loop, and that's where we get the loop body. The actual code that executes for every iteration of that loop. And we use that keyword there, iteration, right? Or that terminology there for iteration. So let's just go ahead and get things started here by showing you a simple for loop. For int I equals 0, I is less than 10, I plus plus, right? And I'm going to go system.out.println I. Right, there we go. Oops. All right, format, there you go. All right, so it added some horizontal spacing here that normally I wouldn't do, right? Especially in a for loop here. I like to compactify things a little bit, so I'm going to go ahead and restore that, right? So take a look at the syntax here. We've got the keyword for. That's why we call it a for loop. Here are the 3 conditions that I would just mention. Here's the initialization. This is where the loop starts. We have this iterator variable, or this iteration variable, right? I'm just calling it I because it's just a generic variable, right? That's idiomatic. That's usual to call these things I. It starts at 0, so you start at I having a value of 0. This is the continuation condition. While it is still the case that I is strictly less than 10, we will execute this loop one more time. Right? And then we've got new syntax here, and if you've never seen this before, especially if you're coming from a Python background, Python does not allow you to have this syntax. I plus plus. It simply adds 1 to the variable I. So if it starts at 0, I plus plus goes to 1, I plus plus goes to 2, I plus plus goes to 3, etc. Right? And it ends up printing this out. So predict really quick here, when I run this, what's it going to end up printing out? What's the first thing it's going to print out? 0. What's the last thing it prints out? 10, 9? All right, let's find out. It was only 9, right? Because when it's 10, is 10 less than or equal to 10? Strictly less than 10. 10 strictly less than 10? No. So we don't end up executing this. And we end up breaking out of this loop, coming down here, system.out.println, done. Right? And so after 9 has been printed, then we jump out of that loop terminates, and it continues with the normal sequential control flow in the program. Now normally I would take this over to a code visualization tool called Python Tutor, but I'm going to take this as an opportunity to show you another tool in Eclipse for Java here called the debugger. I'm going to go ahead and come over here and double click, and this little blue dot right here, that's what's called a breakpoint. We're going to look at debugging later on and see you're going to use a debugger called GDB. I want to show you the internal workings of this program step by step, right? It got done in a microsecond right there, right? It just printed out everything. I want to slow this down, and I want to show you each iteration of the loop and what happens. So I'm going to go ahead and set a breakpoint here, and then you see this, instead of hitting play, I'm going to come over here to this little bug, right? And that's called debug, right? So let's go ahead and it'll ask you maybe the first time, do you want to go into the debug perspective? Just say yes. And this debug perspective here has paused the execution of the program at my breakpoint here, right? So it hasn't printed anything yet. And I can look at variables over here. For example, args. There were no arguments given to this program. Let me go ahead and step through. If you take a look over here, you've got this resume, right? You've also got stop, and you've got this step into and step over. So what I'm going to do is I'm going to step over this, right? And you see over here that the variable I is now in scope, right? The variable I now exists. What's its value? Over here, 0. Or if you highlight it, then it'll print it the value right here, right? So let's continue. Let's go ahead and step another iteration of this. Once it executes line 8, what's going to happen? It prints 0, and then it comes back up to the for loop here. And let's now step into this, right? And what happened to my I over here? It got incremented to 1. Why? Because this executed, I++. When did it execute? Did it execute at the beginning of the loop or at the end of the loop? Which one? Well, if it executed at the beginning of the loop, say right here, what would I have printed out first? If I start I at 1, and then immediately at the beginning of the loop, or sorry, if I started out at 0, and then immediately at the beginning of the loop, I incremented it by 1, right? Then what value would be printed first? 1. So what does that tell you about that I++? It occurs at the end of the for loop, right? We can go ahead and continue stepping through this. You'll see over there on the right that it goes to 2, 3, 4, 5, 6, and you'll see that it's being printed at the bottom here, right? 9. So it prints out 9, but it comes back up here, and it increments I++, but then it checks. Is 10 less than or equal to, or strictly less than 10? No. So it jumps out of the loop, and we go down to line 13 here. Right? Now note here, what happened to I? Is that variable valid anymore? Nope. Let's go ahead and stop this, using the stop button over here. And let's go back into our Java perspective. And let's try to print it out. Done. Now I is ... And then I'll concatenate the value of I here. What's going to happen? Does that compile? No. What does that tell you about this variable I right here? It's local to the, it's scoped to the for loop, right? It does not exist before the for loop. It does not exist after the for loop, right? So keep that in mind. Yeah. Good question. We haven't gotten to methods yet, but if you had a method, then you could step into that method and then start debugging that one line by line, right? Step into is just simply, well, if you're about to call this function, if I wanted to step into this, where am I going to end up going? To the println function. But of course, it's not even going to run because it's not compiled. But let me go ahead and get rid of this and show you that I'll set another breakpoint down here. To get rid of a breakpoint, you double click it. To create a breakpoint, you double click over here. So let me go ahead and run this as a debugger. And if I were to step into this, where does it take me? To the println function, right? And if you've got the full JVM code attached, you can actually start going through it. Of course, you're not going to be able to make any changes to it, but you can start stepping line by line in there. If you don't have any control over that code, though, you probably aren't going to be successful at debugging it. Right? That's somebody else's problem. All right. So some things to note here, or some observations with for loops. Well, first of all, oh, and by the way, before I do that, let me take this and cut and paste it over here into my thing, my VS Code over here. And except for, of course, this print statement, which I would use a printf instead, I is equal to %d and the line I. There we go. Did I have to change anything? Let's find out if that works. GCC demo. There we go. Run it. Same exact behavior. Same exact syntax here. Right? There's no translation needed for for loops in either language. Okay. It uses the keyword for, obviously. Otherwise, they wouldn't be called for loops. They'd be called something else. All three elements are on the same line. Right? The initialization, continuation, and the increment. Right? And let me go ahead and cut and paste what I did before so that you have it. I'll go ahead and paste the C version here. There we go. There we go. All right. They're all on the same line. There's the initialization, there's the continuation, there's the increment. But what else do you notice about the syntax here? Where are semicolons? Are at the end of the initialization, continuation, but not, in fact, I'll emphasize that, not the increment. Right? Why? It's an executable statement. It should have a semicolon at the end of it. Don't ask me, I didn't write the thing. Right? 50 years ago, we can go back in time and correct our mistake and say, that's inconsistent, you shouldn't do that. But they made a decision 40, 50 years ago to have syntax like this, and we're living with it today. Right? I think if I had to conjecture why that is because it's got three things. It's the semicolon, they treated it more like a comma here, right? To separate those three things, and you don't need a comma at the end of it. Right? So that's just my guess. But understand that that is, in fact, the syntax. Okay? Another observation, the increment statement is executed at the end of the loop, right? Because we already we witnessed that if it had not, then we would have had different behavior. And another observation is that the continuation condition is checked at the start of the loop. To show you what I mean there, let me go ahead and go back to our Java example here. Let's suppose that I started out at a different value, 1,000. All right, oops, ignore that. Stop. Something was still running. I'll go ahead and stop it there. What if I started at 1,000 and I is less than 10? Will this execute at all? This loop will execute at all? Nope. Instead, done. Now I is, right? Why? Because it starts at 1,000, it checks this continuation condition at the start of the loop, before even the first iteration. And is 1,000 strictly less than 10? No. So it doesn't execute. Okay? Another observation. The above syntax limits the scope of the iterator variable I to the loop itself. Right? It does not exist before or after the loop. This is a very good thing. Right? VGT, it is a very good thing. You want to limit the scope of variables as much as possible. The worst possible thing that you could do is have what's called a global variable. A variable that you end up declaring outside of any function, right? So let me go ahead and show that what that looks like in C. Int number of students, right? This is a global variable. Globals are evil, right? You might see that term, it's not my term, that's a common term among software development, right? Globals are evil, right? Why? Because if something is a global variable, then any piece of code can see it, any piece of code can change it, and therefore you need to test for every single possibility of any piece of code changing it, right? Chaos. You want to limit the scope of variables so that you limit those side effects. And the worst thing that you can do is have a global variable, right? You can have global constants. Pi does not change, right? That's perfectly fine because nobody can change it. But a variable, nope, globals are evil. Don't do that. Right? Bad design. So there's our 3 observations. Let's make another observation on new syntax, right? The I++, right, adds 1 to the variable I, right? Do you think that there's another one like it? I minus minus, yes. What does that do? Subtracts 1 from the variable I, right? There are prefix versions where you can do plus plus I and minus minus I. Ignore them. In fact, I'm not even going to retain that in the notes. I'm just going to tell you that they do in fact exist. Don't use them. Why? Because there's a very subtle difference between them, right? And if you rely on that subtle difference, then eventually you will forget what the difference is, and then you will misuse them back and forth. I honestly don't remember what the behavior is of one over the other. I don't want to have to retain that arcane, stupid knowledge in my head, right? Instead, I want to write nice, clean code. I'm just going to use one of these things and be done with it. I just want to add 1 to I, right? I don't want to use the side effects that are associated with the 2 different versions of there. If you want to know what the side effects are, read all about it, I think in the book, right? I think I did put that in the book, right? But you also have other versions of this stuff. By the way, anybody coming from a Python background, can you do either one of these things? Nope. Why? I don't know. Every language supports this except for Python and I believe Swift. And Swift supported it at one point and then took it away just to be different. I believe that Python doesn't support this because, again, we're Python. We need to be different, right? But they do support, weirdly enough, the other versions of these things, the compound assignment operations. This one adds 10 to the variable I, right? I plus equals, right? It's equivalent to, if I had simply just written I is equal to I plus 10, right? Shorten that up, there we go. Right? Variable. There we go. All right, that way you aren't just stuck with 1 all the time. 1 is certainly the most common because it's idiomatic. You use these in loops all the time. 0, 1, 2, 3, 4. You're going to eventually use them for index variables for an array, right? Likewise, because you have plus, you can also do things like minus equals 5. And what does that do? It subtracts 5 from the variable I. And you're not limited here to plus and minus. You can also use, say, I times equals 2, right? This doubles the value of I, right? And you can also use I divide equals 2, right? To divide, divides by I, by 2. Careful. Why do I say careful here? 10 divided by 2 is what? 5. 11 divided by 2 is what? 5. Why? Because I'm dividing by an integer here, right? Now, if I had done something like 2.0, then that would probably result in 5.5. But since I is an integer, it can't hold 5.5, and therefore it gets truncated anyway. Right? You can use these things with doubles if you want to. Generally, it's not always done like that. There are plenty of use cases for it. But in the current context of loops, you generally only use integers as index variables or as iterator variables on your loops. Okay? Okay. So, you can do it with doubles, but in general, you want to avoid double variables as your increment variables. Why? 1/3 plus 1/3 plus 1/3. Is that equal to 1? Nope. It's equal to 0.999999, right? It's not math, it's computers, right? And computers are finite objects with finite representations, imprecise. The companion here is the while loop, right? The while loop uses the keyword, what do you think? While, right? Spoilers there, right? The while keyword. The main difference is that all three parts, that is the increment, are not on the same line, right? So for example, the initialization happens before the while loop, right? The continuation is associated with the while keyword, and the you have some flexibility on where the increment happens. Right? So what I mean by that is, let's come over here to, I don't know, the C version. I don't know, Java version. Let's go what? Java. Right. And I'll just go ahead and go, no, I'll leave it like that for now. All right. So a while loop looks like this, right? Now the initialization has to happen before the while loop begins. So I've got int I is equal to 0, right? This is equivalent to what I was doing in the for loop. Right? And then you put the continuation condition inside parentheses attached to the while condition, or the while statement, while I is less than 10. Right? And then here's where you have some flexibility on where the increment happens. Right? I could go I++, and then print it, system.out.println I. Or I could put it at the end. Right? Now, at this point, predict what this is going to be. Let's walk through this without having to use the debugger. I is 0. Is 0 strictly less than 10? Yep. So we come in here, what's the first thing we do? We print I, which has a value of 0. Right? Then at the end of the loop, we increment I. So what's the first thing that we print is going to be 0. What's the last thing that we print? 9. Right? It's absolutely equivalent to the for loop that we just wrote. But what if instead I chose to use the flexibility and do that increment before the print statement, at the beginning of the loop instead? Now I is 0. 0 is strictly less than 10. So now what's the first thing I do when I come into the loop? I increment from 0 to 1, and then I print it. So 1 ends up getting printed first. Now what's the last thing that's going to get printed here? 10. Why? The continuation condition is still checked at the beginning. So when I is 9, right, then 9 is less than 10. We come in and increment I. Immediately to 10, printing it out, and then we come back up to the top of the while loop. 10 is no longer strictly less than 10, so the while loop is done executing and it jumps out of here. The other thing to realize is that, do I now have I after the while loop? Yep. Why? Because I declared it before the while loop, and so it's scoped to the entire method here. So that's the other big difference with the while loop. You cannot scope your variables down to just the while loop. If you tried something like that, it's not even going to compile, right? Int I, right? Can't do that. Not syntactically correct. So some differences here. You can place it at the start or the end or somewhere in the middle of the loop body, right? The continuation condition is still checked at the start of the loop, right? But you cannot scope a variable to the loop itself, right? You cannot limit the scope of a variable to the loop itself. So if you want to limit the scope, you're probably shopping for a for loop. If you don't care about limiting the scope, maybe a while loop is better, right? We'll talk about the subtle differences on when would you use one over the other eventually here, right? But before we do that, anything else over here? I'm going to be super flexible. What if I don't increment it at all? Predict what's going to happen here. I is 0. Is 0 less than 10? Yep, print out 0. Come back up. Did I change I? 0 is less than 10. Print 0. Print 0. Print 0. Print 0. Print 0. That is an infinite loop, right? It's not going to stop until my computer dies or whatever, right? The first law of thermodynamics? Object in motion tends to stay in motion unless acted on by an outside force, right? That's what this is, right? So the outside force is going to be me. I'm going to stop it. Stop button right there, right? That kills the program. What happens when you do something like this in C over here in VS Code? Well, you can't do that. Printf %d and the line I. There we go. All right. So GCC. First of all, the compiler complain, hey, you got an infinite loop there. You can't do that. Nope. There might be some compilers that can do some dynamic analysis to detect infinite loops, but sometimes you want infinite loops. Think about your operating system, right? It's in an infinite loop, sitting there waiting for you to click the mouse or type something, right? You want an infinite loop. That's called a pull loop, right? Should I, is there anything for me to do? No. Is there anything for me to do? No. Is there anything for me to do? Somebody move the mouse. Oh, there's something for me to do now, right? Change the little cursor's position on the screen, right? Sometimes you want that stuff, but if you don't want that stuff, right, and it just simply prints out 0 forever, how do I kill it in VS Code? Control C, right? Control X also might work, but Control C is the standard. And I believe that that's going to be the same on Windows because all of them have control there, right? Okay, so careful. Infinite loops, kill it with Control C in C VS Code, right? Or the stop button in Eclipse. Okay. All right. Let me go back over here and show you one more thing that I wanted to show you. This is just a preview. Since this is the honors section, I generally cover things that I don't cover in the main section, and well, because we're covering Java here. Let's see the behavior here when it actually increments to I. All right, so remember that what was the behavior? It prints 1 through 10, right? I wanted to witness, well, I don't understand loops. What I want to do is I want to see it line by, step by step, but only when I get to, say, 9, because I don't want to waste my time. Okay, I understand why it's going 1, 2, 3, 4, 5, but I don't understand how it goes from 9 to 10. Right? I'm going to show you a trick here. Right? So I'm going to go ahead and create a conditional breakpoint. And let me go ahead and go over into the, over here. Let me stop this. And so where's my breakpoint here? This is demo main here. I'm going to make this conditional. Okay, so over here you've got your variables that you can look at variables. Over here you've got all your breakpoints. I'm going to go ahead and disable these others. Those are in other programs, right? So it's showing you all the breakpoints in your entire project, in your entire Eclipse. This is the one that I'm looking at right now. I'm going to come down here and make it conditional. I'm going to make it conditional on the fact that I is equal to 9. Right? Now it's not going to stop at the first time that it gets here, right? Instead, it's only going to stop if and when I hits 9. Right? Let me come over here and show you the variable I. Oh, okay. Come on. Keep going. There we go. There, it stopped, right? I must have 2 breakpoints there. I'm not sure. Oh, I'm not sure why it stopped initially. But you see that it stopped because it's still going, right? I still have this breakpoint, or I still have the stop button down here. If I look at I, it has a value of 9. That allows me to, suppose it wasn't just 1 to 10. Suppose it was 1 to 1,000,000. Are you going to sit there and go click, 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 click 1,000,000 times just to get to that one value that you're interested in? Nope. So you set a conditional breakpoint to stop this program when I hit 999,999, right? Or in this case, just 9. So that I can witness what happens when we get to the end of the loop. So I is 9, great, 9 is less than 10, I understand that. Oh, okay, I see it now, I++. We go from 9 to 10, and then we end up printing it out, right? And then I end up coming back up to the while loop and seeing that 10 is not less than 10, that's why we break out, right? So, very, very useful tool, debugger, right? And you'll get more practice with it later on. But I wanted to show that to you so that you're not just, fiddling around in the dark when it comes to debugging your programs. Right? If you want to really get into it early, I've got a video that I can share with you. Okay. All right. So Which one? Which loop is best? Right? Or why do we even have two loop control structures here? We actually have three, actually four, if you want to get technical with Java. While loops, for loops, do while loops, which I'm not going to cover, right? So any observation here, any for loop can be rewritten as an equivalent while loop and vice versa, right? You can take any while loop and you can make it into a for loop, right? So why do we have two, right? Well, why do we have this syntax up here? I++, I plus equals 10, right? Ask you another question. Why do we have so many adjectives in English? Right? We don't just have one adjective for good, right? Fantastic, exceptional, stupendous, right? Why do we like to have more words to describe the same thing? Nuance, right? Context, right? A connotation. It makes a language richer. This is in the context of code, this is called syntactic sugar. If you're just eating bland cereal, I don't know, do they serve oatmeal in the dorms? Can you get oatmeal? All right, so oatmeal is kind of bland, right? It's reasonably healthy for you, maybe way too many carbs, but you still eat it, but I don't like it, right? So what do you put on your oatmeal to make it taste better? Brown sugar? Okay, sugar, right? But brown sugar, right? Instead of just regular sugar. I don't know. Does anybody put hot sauce in there? Oatmeal? No? Okay. So brown sugar or regular sugar. Why? Because it makes it taste better. That's the same thing with syntactic sugar. It makes it easier to understand and quicker to read. Once you understand the nuance, of course, once you understand the language, it makes it easier and more flexible to use. Plus plus, I don't have to write I is equal to I plus 1. Right? That's what you would essentially have to do in Python. I plus equals 1. Okay, that's a little bit shorter, but woo, I plus plus, that's even shorter. It's shorter to write, it's shorter to read, it's quicker to understand. Right? Likewise, sometimes you might want to use a while loop, sometimes you might want to use a for loop, right? In general, and again, you can be really weird and always ever. I hate while loops. I hate the word while. I hate W's for some reason. Right? I'm only ever going to use a for loop. You can go through life like that, right? But in general, you use a for loop when the number of iterations is known up front, right? It could be fixed, like say 10, or variable, n, right? So for example, if I were to change this into a more general for loop, int n is equal to 100, for int I is equal to 0, I is less than n, I plus plus, right? Then I'll go ahead and go with system.out.println I. There we go. And I don't have I anymore. There we go. All right. So if I wanted to put this into a variable, fine. But I know exactly how many iterations this for loop is going to go. How many? 100, 0 through 99, right? I know up front, it could be that this was read in by the user, right? And so you wouldn't know when you actually implement the program that it's going to be 100, because somebody could run it by putting in 15 or something like that. But you do know that it's controlled by this variable. You know up front exactly how many iterations are going to go with this for loop here, right? But in a while loop, you generally use that in general, you use a while loop when you don't know how many iterations are going to execute, right? Here's an example. Write a loop to determine how many digits an integer has. Right? So for example, we'll do it in C or Java. It's going to be C? Okay. It's going to be exactly the same thing. I'm going to copy it over and change my print statement, and that's it. Right? So let's go ahead and start with an example here. Suppose that int n is equal to 1234, 1,234. How many digits does that number have? 4. because I wrote it, right? We see it. 5, 6, 7, 8. How many digits does that have? 8. But that's because I wrote it. What if we read this in from the user, right? A to I of argv sub 1, right? How many digits does that have? Well, if I ran this with 1, 2, 3, 4, the answer would be 4. If I ran this with 1, 2, 3, 4, 5, 6, 7, 8, the answer would be 8. We need to write a loop to determine that. So let's go ahead and create a variable here, int num digits. What value should I start it at? All right, we'll come back to that then. All right. So suggestions on how to do this. Let's start out with whiteboarding it, right? And I'm not going to do a whiteboard here because it won't show up on the live stream. Instead, I'll do the whiteboarding by typing it out here, right? Whiteboarding is where you write out some ideas on a whiteboard because presumably you are working with somebody, right? And so everybody needs to see it, and so that people can scout out, oh, well, maybe if you did that, right? It's a way of collaboratively doing things. That's why we have these things, whiteboards, right? 1, 2, 3, 4. How do I go about counting the number of digits in there? Now, there are some advanced tricks that you might say, well, convert it to a string and then count the number of characters in it. Right? That's easy. Right? We're not there yet. Oh, what if I were to divide it by 10? And I now have 123.4, but if I did integer division, what would it end up being? Truncation, 1, 2, 3. I did that once. I did that twice. I did that thrice. And I don't know how, twice? 4 times, right? Until I got to what? What's left? 0, right? So here's my outline. Divide by 10 until you hit 0. Do I know how many times I'm going to divide by 10? Sometimes it's going to be 4. Sometimes it's going to be 8, right? I don't know up front how many times this loop is going to execute, suggesting to me that I should have a while loop instead of a for loop. I could write a for loop, but that would be really weird. Do I know, if I knew, all right, run this loop, divide by 10 4 times. I've got my answer in my hand already. Right? Run this for loop and divide by 10 8 times. I've got the answer in my hand already. Why am I doing this? Right? There might also be some mathematical things that you can do, right? How many digits are in a number? That's the whole point of log base 10 of n, and then you take the floor of it, or the ceiling of it, right? That tells you how many digits are in there, right? But that's a math trick, right? We don't know that math trick. We just know coding, right? All right, so while, divide by 10 until I've hit 0. So here's my n. While n is greater than or equal to 0, I don't know. When it hits 0 and I divide by 10, what's it going to end up being? N is equal to n divided by 10. There we go. So I've hit 0 now. Suppose that I read in 0 instead of some number, right? So 0 divided by 10 is 0. Well, 0 is greater than or equal to 0. 0 divided by 10 is equal to 0. 0 is greater than or equal to 0, right? I've caught myself into an infinite loop here. What should I have done instead? Strictly greater than? Okay. And each time I do this, I'm going to say num digits is equal to num digits plus 1. Because I divided by 10, 1, 2, 3, 4 goes down to 123, there's 1 digit. 123 goes down to 12, there's 2 digits. 3 digits, 4 digits. I've hit 0, and I'm done, and I print it out. System.out. Oh, wait, sorry. Printf number of digits is %d and the line. Num digits. Okay? So where do I start it out? We'll start at 0, let's say. All right. CCC demo. All right. No syntax issues here. Obviously, it's going to segfault because I didn't give it any input as command line arguments. Let's go ahead and try those 2 test cases that I already whiteboarded, right? The 1, 2, 3, 4, I should get an answer of 4, and I do. The 1, 2, 3, 4, 5, 6, 7, 8, I should get an answer of 8, and I do. Right? If I go with 777, I should get 3, right? All right, it works. Done. Nope. What was the whole point of you having to write extra code if you did the C version yesterday of to test your leap year function? Right, we only gave you 3 test cases. We asked you to do 3 more. Why did we ask you to do those test cases, that informal unit testing? To give you better confidence that it was actually running, right? If you saw that one of those test cases was failing, that was a huge red flag to you that, no, my code is wrong, right? My condition for determining whether if something is a leap year or not, it's wrong. I need to go back and fix my I need to go back and fix my code, or it could be very well that I'm getting a false negative there, and my test case is wrong, right? It's the year 2000, and I say that, oh, that's not a leap year. Yes, it was, right? So how else should I be testing this? What about 0? How many digits does 0 have? 1, right? That's wrong. That's an edge case. Maybe I want to take care of that separately, right? What's one solution here? Oh, that's wrong. So I need to go ahead and go num digits is equal to num digits plus 1. There, I fixed that bug, right? But I need to do some regression testing, right? What if I go back to 777? What's the answer going to be now? Now I'm off by 1 the other direction. So I fixed 1 test case, I've whacked 1 mole, but now I've got, that pops up 50 other bugs, right? Nope, that's not the solution. Treat things differently, right? If you've got a aberrant edge case, write special code for that one case. So for example, in calculus, right? 1 divided by x, right? Is that function well behaved? Everywhere except where? At 0. So you treat that differently, right? Otherwise it's differentiable everywhere, right? You can take the first derivative of everything except at 0. So we'll go ahead and treat 0 differently here, right? If I don't know, n is equal to 0, then we'll go ahead and say that num digits, or we'll print out this message. Number of digits is 1. We won't even have to do that, right? And then we can go ahead and exit. Here I'm going to exit 0 because everything was great, right? That's not an error condition. You asked me how many digits are in 0. I told you 1. We're good, right? Now, 777 works. 0 works. Ship it. Negative 777. What's going to happen here? Zero. Why? Negative 777, is that greater than 0? Nope. So we never even execute this while loop. Solutions. Yeah. Okay, I could do it like this. While it's not equal to 0, and I'm pretty safe there because I've already taken care of this edge case first, right? And I believe that this will work. 3 digits. We don't count the negation sign. Do some regression testing to make sure that things that were working before are still working. Working. 1, 2, 3, 4. Working. 1, 2, 3, 4, 5, 6, 7, 8. Working. Right? And this is why we had you code those unit tests. Because if you were to do ad hoc testing like this over and over and over again, right, you fix one bug, you repeat all of the work that you just did. Right? But if you wrote other code to test this code, all you have to do is click a button and run all those automated tests, right, and be done with it. Right? Rather than doing, type, break, okay, fix, type. Right? All right. Another alternative solution here. Think math. Yeah. absolute value. All right, n is equal to the absolute value of n. Is that the correct abs? Yes, that's for integers. Sometimes you need fabs for floating point numbers, otherwise you'll get truncation. I won't get truncation here because this is an integer. Right? And now this takes care of everything. Right? GCC. Rerun your automated test suite and be done with it. Some other optimizations before we adjourn here. N is equal to n divided by 10. Is there a sugary way of rewriting that? What? N divided by equals 10. It's Wednesday. That's a test. You don't have to do anything.
May I have your attention, please?
And then this one is just simply plus plus.
A tornado warning has been issued for this
But that's where we will end
area.
it.
A tornado warning
So if you want
has
to
been issued for this
practice
area.
your tornado warning
Please
skills,
take
go ahead.
all
Run out.
appropriate safety actions at this time.
All right. See you on Friday.